Howdy, everybody. We're here for day 2 of Advent to Code 2016. Hope you're doing well, wherever, whenever you are. I truly mean that. I wish the best for everyone. So, yeah, day 1, I felt I was a little slow out, probably because I spent some time implementing some things that I only used once. But I don't know. I had fun trying some things out and solving the problem. We'll see if today's harder or easier, um, or maybe I can try and hone in closer on my thoughts to be a little faster and better. We'll see. Who knows? Maybe today will be hard and it'll take me forever to solve. So, with that said, let's just get started with day 2. So this one is bathroom security. It says, you arrive at Easter Bunny headquarters under cover of darkness. However, you left in such a rush that you forgot to use the bathroom. Fancy office buildings like this one usually have keypad locks on their bathrooms, so you search the front desk for the code. In order to improve security, the document you find says, bathroom codes will no longer be written down. Instead, please memorize and follow the procedure below to access the bathrooms. Okay. The document goes on to explain that each button to be pressed can be found by starting on the previous button and moving to the adjacent button on the keypad. Up moves up, down moves down, L moves left, and R moves right. Okay. Each line of instructions correspond to one button, starting at the previous button, or for the first line, the 5 button. Okay, you start at 5 and then up would take you to 2 and so on and so forth. Press whatever button you're on at the end of each line. If a move doesn't lead to a button, you ignore it. You can't hold it much longer. If a move doesn't lead to, like if you go up multiple times, I think is what that's saying, is like if you're at 2 and you do up, you just ignore the up. You can't hold it much longer, so you decide to figure out the code as you walk to the bathroom. You picture a keypad like this. Yeah, this is a traditional keypad. Not like the keyboard one, but one like on an old telephone or whatever. Suppose your instructions are up, left, left. So up, go here, left, left would be a 3. Oh no, left would be a 1. Left this way. Yeah. You start at 5 and move up to left 1, and left you can't move, so you stay on the 1. So the first button is 1. So let's try these. Right, down sticks you at 9. Yeah. Left, up, right, down, left puts you at 8. Yep. Finally, you move up 4. 1, 2, 3, 4 down gives you a 5. Yep. So in this example, the bathroom code is 1985. Your puzzle input is the instruction from the document you found at the front desk. What is the bathroom code? And here's the puzzle input. Okay, so like a really long line of instructions. Yeah, these would be memorizable, obviously. No one's using the bathroom in this office building. But okay, let's try part 1. So for this, what I'm thinking is we probably just make this keypad in as like an array, and then we like start at this position, and then we just say, can I move up, down, left, or right? Meaning we're subtracting. And if I can't move, then I just don't move based on those directions. So these ones will probably be easier than yesterday because I can just have deltas for these, right? Up is 1 or 0, 1. Left is would be -1, 0. And we just kind of move our current thing around, and we do it for all the instructions on a line. Okay, yeah, I think that's how you do it. So let's AOC watch day 2, and then let's start right here. So what is our, how are we parsing our input then? I think it's actually going to be a vec car. So we'll do lines, and then we'll do map l.cars.collect, like that. So and then we're not going to get a usize. It's going to be a string, I guess. I guess I don't know what part 2 is, but we should just assume. Like that. What doesn't like about this? Oh, I didn't save. Okay. I was like, how? So if we do like a const it's like a 3x3. Like that. Oh, this is I'm gonna get rid of like that. Okay. So I'm gonna do like 4 moves in input, and then I'm gonna do like 4 move in moves. I'm gonna do some work here, but in here eventually, so we'll say let her equal, we're starting at 5 or at 5, right? So which is 1 1. I guess we can just do x y like that. I don't know if we'll need a point. We'll find out. But then here we'd say code dot push, or code dot, all right, push, and it would be pad y x. Oops, it's like that. So we got to make this mutable. So now we just have to figure out how to do these movements. We can probably have some deltas too. So const delta. Do I just do a once lock thing or whatever? Is it called a once? What is the equivalent of a wait or a lazy? Once sell, is that right? Sorry, I guess I should move this over here. This is like sort of pedantic Rust, like I'm worried about how to use lazy static. I know they have like a once lock. I think I've used it before. Maybe we just ask like ChatGPT. So I say, hey, what is it? Once lock. So you do a once lock of a value and then you do configure get. Okay. So it's like it is a once. Oops. Lock of a hash map of car and then I size. Did I do that right? This feels very verbose. I almost don't want to do this, but we'll try it just for fun. I want to return a hash. Oh, I should change this to fx hash map, right? So then this is delta dot get or init. And then this is where we put our stuff. So we would say like we can do this, and then we can do up goes y in the positive direction. What doesn't it like? Oh, I need to return a pointer. To a static. One of these. Okay, what doesn't it like now? Value of hash map car I size cannot be built from internet. Car integer. I swear you could do this. Isn't that right? How do I build a hash map from a vector of key value pairs? I swear we've... Oh, from iter. Hash map from iter. Is that really it? Oh, maybe it's that the FX hash map doesn't do it. Like if I remove this, does it magically work? Still doesn't like it? From iter, blah, iter. Oh, I have to do like this. Oh, that made it worse. What if I do this? It really doesn't like me. Lazy static seems so much easier. Oh, it needs to be a static stir. But it's a car. Maybe it just doesn't like that I'm doing it like this, so I let pairs equal this. It still doesn't like it. So yeah, this is just me not knowing. Oh, it says LazyLock. Maybe that's what I want to do. LazyLock. Let's try this one. Okay, so I feel like we spent 10 or 15 minutes just trying to do that part. Sorry. Okay, so the lesson there is use LazyLock. Okay. So I still have to build this. So up, down, left, oops. Left, right. So if we're going down, this is negative. Left is negative. And right is like this. Is that right? Up goes X, Y, 1. Down goes X, negative 1, or Y, negative 1. L goes X, negative 1, and R goes plus 1. Okay. So now I think we just need to try and move our positions. So we'll say let new X equal X plus, let's see, let D delta equal delta get M. And so this would be X plus delta 0. And the new Y is Y plus delta 1. So this is get our new positions. We probably should trim these. I think it'll work without, but just in case, we'll trim them. And so we just need to ask some questions. We should say like, if new X less than 0, or new X is greater than or equal to 3, right? 0, 1, 2, 3, or new Y is less than 0, or new Y is greater than or equal to 3. We want to continue. Like, we can't do this move. Otherwise, we'll say X equals new X and Y equals new Y. So we've just changed the X's and Y's. And now we presumably are in a position where we can say X as new size. Oh, I guess I gotta make these mutable. What doesn't like here? What does that even mean? Temporary value dropped while borrowed. Delta colon temporary value is freed at the end of this statement. Oh, this kind of wraps it. So like I probably have to clone it, get my own value. Oh, did you see what happened there? I think this watch, I don't know if it's Windows or what, but this watch command doesn't work very well. Is that it, do you think? That is not. It's too high. Oh, why would I click on 5? Is that it? Why would I? I'm a little nervous about this. I'm inclined to do my test. Do this test right here. Yeah, that's not right. So if I'm at, I know I want to start at 1 1, and up goes x plus 1, down goes, sorry, y plus 1, y minus 1, x minus 1, r minus 1. So for each of the moves, we'll just try it here. Okay. Up, left, left. This should definitely be a 1, right? Do I have this in the wrong order somewhere? 1, 2, 3, 4, 5, 6, 7. I do have these the wrong way. Worse? So up goes -1, down goes 1, left goes, oh, these are still negative and positive. Had the orders wrong. 1965, was that the code? No, it was 1985, right? Left goes -1, right goes 1, down. The 8 is the 1. If new x is less than 0 or greater than or equal to 3, right? 0, 1, 2, 0, 1, 2. I'm just trying stuff because I think I'm, there we go. Yeah. It was reversed. Yeah, you think of the y, remember, because you've got rows and columns, and so like you're going y's are this way, which is actually the first set, and x's are this way, which are the values in it. Okay, so I think that's right. So now let's do this and do this. Hopefully we got the right answer. We did. 1 gold star. Okay. Not too shabby, although that still took a little bit of time. What was my holdup? I think a lot of it was the once lock. So LazyLock is easier, and I got to remember to clone it. And then I definitely overcomplicated this because I could have just put this in here, right? Like eliminate like 90% of my stress and just put it like right here and use it. But then this was all easy. Where was the bugs? These were not right. Like this is right in a Cartesian product, but like a what do they call it? Graph, like a Cartesian graph or whatever, but not right when we're talking about arrays of dimensions. So I had those ordered wrong. Those were my two big mistakes in part one. But let's look at part two. You finally arrive at the bathroom. It's several minutes walk from the lobby, so the visitors can behold the many fancy conference rooms and water coolers on this floor, and go to punch in the code. Much to your bladder's dismay, the keypad is not at all like you imagined it. Instead, you're confronted with the results of hundreds of man hours of bathroom keypad design meetings. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. You still start at 5 and stop when you're at an edge. But given the same instructions as above, the outcome is very different. You start at 5 and don't move at all. Up, left, left for both edges. So you end at 5. Continuing from 5, you move right twice. 1, 2, and then down 3. 1, 2, 3, which gives you a D. Then from D, you move 5 more times. D, B, C, C, B, D. Oh, B. So you end at B. Finally, after 5 more moves, you end at 3. So given the actual keypad layout, the key would be 5DB3. Use the same instructions as your puzzle input. What is the correct bathroom code? Okay, it becomes harder because now you have like it's not actually an array, but I think we fixed that by just putting like blanks in these spots, if that makes sense. So it'd be a 1, 2, 3, 4, 5 by 5 now, and we put blanks and we don't consider them if it's outside of the 5 by 5 range. Is that all that changes? So this paste in here, and then what do so yeah? How do we want a new pad? So let me just call this P2 pad, and it is going to look different, huh? So I want to it's now a 5 by 5. So like this, and it goes 1, 2, 3, 4, and then 5, 6, 7, 8. No, yeah. 5, 6, 7, 8, 9 are A, B, C, and D. So like that's the new pad. What is it? Oh, these are now 5 by 5s. Like that. So we do this. We now start at 0, 1, 2, 0. Right? 2, 0. And we're still going to get these deltas, but these are going to be 5 or... So if we're like inside, these will be sure that we continue there. I think the or would cause us to overflow if we went over. It might not though. Like what I'm thinking is we do or P2 pad, Y is U size, X is U size. It's not equal this. Like that's what I'm thinking we want to do. And that just solves it? Maybe? Okay, that can't be right. Oh, gotta use that right there as well. That is also not right. It would be hilarious if it was, but... So we start at 0, 1, 2, 0. Oh, but it's the other way around. The whole thing, I'm tempted to do this just so it's obvious. We can fix it though later. It's probably not 5, 5, 5, 5 either. 0, 1, 2, and 0. Oh no, it's if it equals. Okay. Nothing? So if new x is less than 0 or greater than or equal to 5, new y is less than 0, greater than or equal to 5, or pad y x equals blah, continue. We want to skip. Otherwise, we change our x's and y's. Hmm. Do I just move this somewhere else? Like, if I do this, do I get something out of this? C4 blank D, yeah. Oh, it's not X and Y. It's new Y, new X. That feels better. That's the right answer. 1 gold star. Okay. Yeah, I mean, this one wasn't too bad, right? It was just, I had a lot of bugs in it. It's late in the day. Maybe I'm like out of it. Can I use that as an excuse? Kind of using the same algorithm. I wonder if there's a way to like combine them. That might be worth looking at. So basically, like, you give me a pad and then I'll solve it for either day 1 or day 2. I can't use like consts like this in that case. I guess I could make both of them a 5-5 and then just have the pad in the center for P1. But I feel more like what we want to do is actually put these. So we could try that. We could say fn find or yeah, find code, and you give me a pad, which is a something to a vec car, and a x and a y. I guess these are I sizes. And I'll give you a string. And we want to use the logic here. We should probably just put the deltas in here. Oh, I need the lines too. This. And this is going to be we can call it an fx hash map of car I size. Is it really not like that? Does the fx hack? That? We'll say that for now. Okay. And then this is pad. And then this is pad. Like that. We get our new positions. Verify it's a valid position. Oh, these are also I think this is technically the 0th one. Okay, so then for each of them, I don't think you can do it twice like this, right? I mean, well, what was it at? 1-1? Expected, vec car found, vec car 3, vec car 3. Ow. Oh, there we go. So do I need this? Do I need these? Oh. Yeah, I think I need these ones. But I don't need the other ones. Five 2 9 8 1. Yeah. So then we can presumably do the same here. I can't do that in Windows for some reason. It won't let me box select to do the insert thing. I should figure out how to do that. There's probably another key that lets me do it. And we're starting this time at 0 1 2 0. So wait, the X is 0, the Y is 2. Like that. So I don't need this anymore. Okay. Okay. That feels nice. Clean it up a little bit. Make it look a little bit nicer. So I have like one fine code for both parts. I just have to give them these values in our start positions. Again, we could make these points and have them move. And then we could see if they're in the range. Right? So if you do something like struct point, like that. And then we do fn move to give me a new point. All right, I guess it's not move, but it's all like, I don't know, next. And you give me direction. I'll give you myself so I can match direction. Oops. Sorry, I'm just going through my mind. Is this even worth it? So up, I still want to have maybe this. And I don't return myself. So up, I just do self.x minus equal 1. Like I think I can do this, but it's I'm creating like a new point each time I go around. And again, I may not want to actually move it. So I almost feel like keeping track of the X's and Y's is worth it. I don't know if you were paying attention to what I was doing there. Sorry. But like initially I was thinking, oh, give me a new point based on this direction. But like it'll introduce some interesting logic down here, because like think about what I'll be doing is I'll be saying, I'll basically be saying like this is my cur, for example, and then I'll be like cur plus equals delta or whatever. I'll be given some delta and I'll cur plus equal it, or I'll do next to get a new one, and then I have to ask, are these do I want to move to that new one? And if I don't, or if I do, I set cur to next. Otherwise I don't. I mean, it might still be worth it. Let's try it, see what it looks like. So I actually want to do this, go back to this, and do self.x, self.y minus 1. Oops. So if I go down, it's self.y plus 1. And self.left is self.x minus 1 plus 1. Like that. Okay. So now I have let cur equal to point new xy. Then I technically don't need this anymore. And so I can say let next equal cur dot next m. So that'll give me this, and so I can say next, 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 next. This one's cur. Like that. That give me the same answer? It does. Yeah, okay. I mean, I guess the thing is I was already keeping track of these. So that's probably... I was already creating a variable here for the next X and Y. So I was probably overthinking like the effort of doing that. So, okay. Yeah, so I have some point and then I can do logic on that point. I call next on the point. Then I check its bounds. And then I add that right there. Could I make these U sizes? So I don't have to do all this changing? Like this next would have to have a cap to this to this one right here, right? Like I could definitely use saturating stub to get rid of these. I don't know, is there a saturating let's see. I know Rust has a saturating sub for U size. Is there a sort of saturating add, but you give it the max value you want? So say you want the bounds to be yeah, this is what I'm thinking. It's only like to the maximum value. Oh, but you could write it min saturating add min of the max. So never go above it. Like what that would mean is like these ones wouldn't, it would clamp these. So I'm willing to try that. This, so then so we add one and then do min of max. Like that. So we give it a next direction and a max U size. We can even do, we could do it as lane, and then we could do like this. Like that. So now this will always do these parts. So I can just do this. And this. Right? Is that cleaner? 5290. Yep. Yeah, so it does make it less clear here because we're doing the bounds checking here. Okay. But I do like it better. Just verify its valid position. This will already do it. Do the bounds checking, and so then we just need to make sure is that not a space. If it is, then we don't want to move, right? Like these right here. You'd potentially put the whole logic in here, but I think this is okay for now. Okay, I probably spent way more time than I needed to on this one, but it's kind of fun to play with Rust and, you know, all the different ways that you can do things. I think it looks pretty refined. I'll submit this as is. Let me know how you did it. I'm interested to see how you did it. Maybe you did things differently. I think you could have, especially if you're going for competitive, you probably wouldn't have done a lot of this stuff, right? You probably would have just left it how I had it, and that would have been more than fine. You also, I mean, don't spend time doing these things, like having a LazyLock or whatever, a once lock LazyLock for the thing is like a very small optimization for like conserving memory that doesn't even make sense when you're like, you know, solving problems like this. So that was probably overkill on my part, but anyway, let me know what you think, and I'd love to see how you did it. So with that being said, bye everybody.